Yeah, that thing hasn't transmitted in 11 years, man. It's done. Specialist Jordan Hayes said it with the easy certainty of someone who has just run a diagnostic and has the readout to prove it. He was standing at the radio bench in the communications room of the Zanesville, Ohio National Guard Armory, looking at the AN/GRC 106 HF radio set at the far end of the bench, and a 79-year-old man in a canvas barn jacket was standing beside it with his green canvas case set on the floor and his thin, nimble hands resting on the radio's casing, looking at it the way a man looks at something he already understands. Hayes had a diagnostic tablet. He had run a full systems check on the GRC 106 30 minutes earlier at the request of the unit's new battalion commander, who wanted the radio operational for a memorial ceremony in 3 weeks. The radio had been confirmed as the exact unit that the battalion's signal section had used in Vietnam in 1968, and Lieutenant Colonel Drummond wanted it transmitting for the ceremony. And Hayes had run his diagnostic and found what he had found. Nothing. No signal output. Corroded antenna coupler, degraded oscillator, RF output below measurable threshold. Done. The old man had arrived 20 minutes after the diagnostic. He had signed in at the front desk, given his name, and asked for the communications room. The duty sergeant had directed him without asking why, because something about the way the old man said communications room had made the question feel unnecessary. Now Hayes was looking at him. The wire-rimmed glasses, the spiral notebook in the breast pocket, the plain brown shoes, and the spool of 20-gauge copper wire clipped to his belt, and the green canvas case on the floor. "I appreciate you coming in," Hayes said. "But there's nothing in there that's going to transmit. The oscillator's degraded, the antenna coupler's corroded, the RF output is basically zero. We'd need parts we can't get." The old man looked at him over his glasses. "What kind of wire do you have in the bench stock?" he said. Hayes blinked. "We have some general purpose 20-gauge copper," the old man said. Hayes looked at the spool on the old man's belt. He looked at the radio. He looked at Sergeant Asante, who was leaning against the far equipment rack with his arms crossed and an expression of very careful neutrality. "We might have some," Hayes said. "Good," the old man said. He opened the green canvas case. He produced his personal AN/PRC 77, what Specialist Jordan Hayes did not know, and what the diagnostic tablet had not measured, because the diagnostic tablet was measuring the wrong things, was that Clifford Boone had been operating and maintaining the AN/GRC 106 and its family of related HF radio systems since 1967, that he had spent 11 months as a signals sergeant in the Central Highlands of Vietnam, keeping exactly this type of radio operational in conditions that involved monsoon humidity, red laterite mud, impact damage from indirect fire, and a supply chain that could not be relied upon to deliver the parts a textbook repair would require. That he had learned, across those 11 months, to repair these radios without the parts, using what was available, using what the radio itself could tell him about what it needed, using the specific knowledge of how these systems failed and how those failures could be worked around with wire and patience, and the accumulated understanding of a man who had kept 14 of them alive in the field. He had come to the armory because Lieutenant Colonel Drummond had called his daughter, who had given her the number of the Muskingum County Veterans Assistance Office, which had given her Cliff's address, and Drummond had written him a letter. A handwritten letter, 3 paragraphs, explaining the radio and the ceremony and what she was hoping for. Cliff had read it twice, put it in the drawer where he kept important things, and driven to Zanesville the following Tuesday. If you believe that the knowledge of how to keep a thing alive is worth more than the knowledge of when it is dead, Type signal in the comments right now. Because what Clifford Boone does with 20-gauge copper wire and an hour of patient work in an Ohio Armory communications room is something that Hayes's diagnostic tablet did not have a category for, and that Sergeant Asante described afterward in terms he has not improved on since. He listened to what it needed, and he gave it what it needed. His full name was Clifford James Boone. He had been born in Muskingum County, Ohio, in the summer of 1946, the second son of a telephone lineman and a woman who had worked the switchboard at the county telephone exchange for 22 years and who believed, with the conviction of someone who had spent 2 decades listening to the way signal moved through wire, that communication was the most fundamental human activity and that the people who kept it working were the most important people in any organization, though they were rarely recognized as such. Cliff had grown up around wire and signal. His father had taken him on lineman calls from the time he was 8, driving the county roads in the repair truck, climbing poles when his father would let him, learning the vocabulary of telephone plant, wire gauge, splice, terminal, ground, continuity. He had learned to use a lineman's test set before he learned to drive. He had learned to hear, through the headset, the specific quality of a good connection versus a degraded one, the cleanliness of the tone, the absence of interference, the particular silence of a circuit that is carrying signal correctly and has nothing left to prove. He had been drafted in March of 1967 at 20 years old and had been assigned to Signal Corps on the basis of a technical aptitude evaluation that one Army classification clerk had described, in the margin of the form, as the highest score in this category we have processed this quarter. He had completed Signal Corps training at Fort Gordon in the summer of 1967 and had deployed to Vietnam with the 1st Signal Brigade in October of that year. He had served 11 months in the Central Highlands, first at a firebase near Pleiku, then at a forward communications position further north, where the terrain was difficult and the supply chain was thin and the radio equipment was older than the doctrine that described how to maintain it. His primary responsibility had been the AN/GRC106HF radio sets that provided the long-range communications link between the forward positions and the rear. A link that was, on a significant number of days, the only communications available, because the terrain ate VHF and the helicopters that carried the backup systems had other priorities. He had kept those radios working in conditions that the maintenance manual did not address. The manual assumed a repair facility, spare parts, clean power, and dry air. The Central Highlands provided none of these. What it provided instead was red laterite mud, monsoon humidity that corroded copper contacts overnight, impact vibration from incoming fire that cracked solder joints in ways that showed no visible break, and a power supply that varied by 20% depending on the generator load. Cliff had learned to diagnose these failures not from the manual, but from the radio itself, from the quality of the static, the drift pattern of the oscillator, the specific way the RF output behaved at different temperature and humidity levels, the sound through the headphones of a connection that was about to fail versus one that had already failed versus one that could be restored with the right intervention. He had learned that a degraded oscillator in a GRC 106 did not mean a dead oscillator. It meant an oscillator that had drifted from its calibration and needed to be brought back by a process that was not in the manual because the manual assumed you had the calibration equipment. He had found a way to do it without the equipment. He had been doing it since 1968. He had come home in 1968, completed his service in 1970, and had gone to work for the Ohio Bell Telephone Company, where he had spent 30 years as a plant engineer and then a senior technical supervisor before retiring in 2001. He had never stopped maintaining the PRC-77 and the set of technical notes he had accumulated across 11 months in Vietnam. Not because he expected to need them, but because the habit of keeping a thing in working order, once formed at that depth, did not leave. He had carried the spool of 20-gauge copper wire on his belt since 1968. Not the same spool. He had replaced it many times. But always 20-gauge copper, always on the belt. His wife had found it endearing for 40 years, and then, in the last years before she passed, had found it simply true. It was part of him, and parts of a person do not require explanation after long enough. Hayes had found the 20-gauge copper in the bench stock, a partial spool enough. He had brought it to the bench with the expression of a man who is participating in something he does not understand, but has not yet found a reason to stop. Cliff had laid out the PRC-77 beside the GRC-106 on the bench. He had opened the GRC-106's access panel, the side panel, not the top, which was the panel the diagnostic protocol used, and was looking at the internal layout with the specific attention of a man reading something he has read before. He said, to no one in particular, "The oscillator hasn't drifted as far as I'd expect from 11 years. Someone ran it recently." Hayes said, "We ran the diagnostic 30 minutes ago." "Before that," Cliff said. "The thermal signature in the oscillator housing is older than 30 minutes. Someone ran this radio in the last year or two." He looked at Hayes. "You have a previous diagnostic on file?" Hayes went to the laptop. He found a maintenance log entry from 14 months earlier, a diagnostic run by a previous signals sergeant who had noted no output, RF stage suspected, parts unavailable, recommend disposal. The previous sergeant had run the radio briefly looking for output and found nothing. "He ran it," Cliff said, "which means the oscillator moved. It's not at its calibrated rest. It warmed and then cooled to a new position." He looked at the internal layout again. "The RF output issue isn't the oscillator. The oscillator is drifted but recoverable. The RF issue is the antenna coupler." He pointed with one thin finger at a component in the lower left of the chassis, a small assembly of variable capacitors and inductors that coupled the transmitter output to the antenna connection. "The coupler's corroded at the contact surface," he said. "Not failed, corroded. There's a difference." He looked at Hayes. "Do you have a continuity reading across the coupler contacts?" Hayes ran the check on his diagnostic tablet. "It's reading open circuit," Hayes said. "No continuity." "At the probe pressure you're using, yes," Cliff said. "The corrosion layer is creating a false open. The underlying conductor is intact." He held up the spool of 20-gauge copper. "I'm going to bypass the coupler. Route the RF output directly from the transmitter stage to the antenna terminal with a temporary coupling wire. It's not the permanent solution. The coupler needs cleaning, but it will get the radio transmitting." Hayes looked at the tablet. He looked at the spool of wire. "You're going to bridge across a corroded antenna coupler with 20-gauge copper wire," he said. He said it without quite laughing, but with the tone that precedes it. "Yes," Cliff said, "and that's going to make it transmit. If my read on the oscillator drift is correct, and the RF stage is otherwise intact," Cliff said, "yes, the coupler is the only break in the signal chain. Everything else is recoverable." He was already cutting a measured length of wire from the spool. Asante uncrossed his arms. He watched. "Subscribe to Iron and Honor right now, and tell me in the comments where you're watching from. Because when Cliff Boone connects that wire and keys the handset, and Lieutenant Colonel Drummond hears the GRC-106 transmit for the first time in 11 years. The sound that comes through that radio is something that nobody in the communications room had expected to hear, and that three of them have talked about ever since. The work took 54 minutes. Not because it was complicated. The wire bypass itself took 8 minutes. The other 46 minutes were the oscillator. Cliff had been right that the oscillator was drifted but recoverable. He was also right that recovering it without calibration equipment required patience and a method that was not in any current maintenance document, because it had been developed in a firebase near Pleiku in 1968 and written down in Cliff's spiral notebook in his careful small printing and nowhere else. He talked Hayes through it as he worked. The oscillator in the GRC-106 was a crystal-controlled unit. Its output frequency was set by a quartz crystal, whose resonant frequency was sensitive to temperature and mechanical stress. 11 years of disuse and 2 brief diagnostic runs had left the crystal at a slightly off-nominal operating point. The correct tool for returning it was a calibrated signal generator. Cliff did not have a calibrated signal generator. He had his PRC-77, which he had maintained to calibrated spec since 1972, and which was sitting beside the GRC-106 on the bench. He used the PRC-77 as the reference signal. He tuned the GRC-106's oscillator by ear, listening through the headphones to the beat frequency between the 2 radios' outputs and adjusting the GRC-106's crystal trimmer by quarter turns until the beat frequency dropped to 0, which meant the 2 oscillators were at the same frequency, which meant the GRC-106 was back at nominal. Hayes watched this without speaking. Asante had moved from the far rack to directly behind Cliff. He was watching the adjustment process with the focused attention of someone who is seeing something done for the first time and is trying to understand it well enough to be able to describe it later. Cliff made the last quarter turn on the crystal trimmer. He looked at Hayes. "Key it," he said. Hayes picked up the GRC-106 handset. He keyed it. The radio transmitted, not powerfully. The RF output was reduced because the temporary wire bypass was not as efficient as a properly cleaned and adjusted coupler, but it transmitted. The meters moved. The signal went out. After 11 years and 1 diagnostic that said it was done, the GRC-106 transmitted. Hayes looked at the meters. He looked at the wire. He looked at the old man in the wire-rimmed glasses. He said nothing for a moment. Then he said, "The beat frequency method. For the oscillator. Where is that documented?" Cliff tapped his spiral notebook. "Here," he said. "Nowhere else?" "Not that I've found." Lieutenant Colonel Drummond had come to the communications room doorway 40 minutes into the work. She had heard the sound of a radio being brought up. She had been in signals herself early in her career, and she knew the sound, and she had come to see. She had seen Cliff at the bench. She had seen what was on the bench beside him. She had gone to her office and come back with the unit historical record binder. She had set it on the bench beside the GRC-106, open to a page that showed the signals section roster from the battalion's 1968 Vietnam deployment, a list of names, ranks, assignments. Third from the top, Sergeant Clifford J. Boone, Signal Corps, AN/GRC-106 operator and maintainer. She had not said anything. She had set the binder down and stood back. Hayes had looked at the binder. He had looked at the old man. He had looked back at the binder. "You used this radio," he said. It was not a question. "Not this specific unit," Cliff said. "I used 3 of this model in Vietnam. I recognize the chassis wear pattern on this one, It was a later production run than the ones I started with, but the system is the same. And the beat frequency method, Hayes said. You developed that in Vietnam? Firebase near Pleiku, Cliff said. October of 1968. I had a drifted oscillator and no calibration equipment, and a forward position that needed communications by 0600. He looked at the radio. I had my personal radio, and I had wire, and I had time. I figured it out. Hayes looked at his diagnostic tablet. He looked at the readout that said, corroded antenna coupler, degraded oscillator, RF output below measurable threshold, recommend disposal. He put the tablet face down on the bench. The ceremony was 3 weeks later, on a cold November Saturday, in the Armory parking area. The unit's veterans of the Vietnam-era deployment, 7 of them, ages ranging from 76 to 83, sat in a row of chairs facing the formation. The GRC-106 was on a table to the side, its antenna properly erected, its coupler cleaned and restored by Hayes over the preceding 2 weeks. A full restoration, properly documented, the beat frequency method for oscillator calibration, written into the unit maintenance record for the first time in history. At the appropriate moment in the ceremony, Drummond had Hayes key the radio. It transmitted. The veterans in the chairs heard the sound. The specific quality of a GRC-106 on frequency. The sound that had been the connective tissue of their communications in the Central Highlands in 1968. Several of them were very still for a moment. One of them, a man of 81 named Gordon Fitch, who had been the battalion communications officer in 1968, looked at the radio and then at Cliff and said, quietly enough that only the people immediately around him heard it, "I'll be damned. You got it running." Cliff looked at the radio. The oscillator had drifted, he said. The coupler was corroded. The signal chain was intact. Fitch looked at him. "You always said that," he said. "In the field, that the signal chain was intact, even when nobody else thought it was." Cliff watched the radio transmitting. "The signal chain," he said, "is almost always intact. You just have to find where it's broken and give it what it needs." He looked at Hayes, who was standing at the radio table with his hand on the key. Hayes was writing something in a notebook. Not the unit log, a personal one, small, that he had apparently brought from his own kit. He was writing the beat frequency method. Writing it carefully, the way you write something you intend to keep. There are men in this country who know how to keep things alive that the diagnostic says are dead. They learned it in places where the diagnostic didn't exist, and the thing needed to work anyway. Where there were no parts, no equipment, no calibrated tools, only wire and patience and the specific knowledge of how a system fails and how those failures can be addressed if you understand the system well enough to hear what it is asking for. Cliff Boone has been carrying 20-gauge copper wire on his belt since 1968. Not because he expects to need it, because the habit of readiness, once formed in a firebase near Pleiku with 0600 approaching and a forward position waiting for communications, does not leave a man. It simply becomes part of him. It becomes part of the belt every morning, the same as his watch and his notebook and his wire-rimmed glasses. The diagnostic said it was done. Cliff heard something different. He picked up a wire and proved them wrong. Subscribe to Iron and Honor for the men who hear what the diagnostic misses. Hit the bell. Don't miss the next one. The signal chain was intact. It always almost is. You just have to be willing to listen for where it broke and know what to give it when you find it.